Today we're going to be learning about L'Hopital's rule and indeterminate forms. And this is going back to limits, but it's a good application of derivatives that we have. They're going to help us find limits. Earlier in the year, we used a table of values to find this limit, because when we plug in 0, we get the sine of 0 over 0, which is 0 over 0. This is what we call an indeterminate form. I can't find this limit, but there's a rule. It's called L'Hopital's rule. Helps us convert this limit into one that we can now evaluate. So L'Hopital's rule says if your function values for the top and bottom are both equal to 0, and that your derivative exists, and that g prime of a doesn't equal 0, then I can find my limit by taking the derivative of the top and the derivative of the bottom. Now there's also an indeterminate form where if f of a is infinity, so there's an asymptote, and g of a is infinity. So your two indeterminate forms are 0 over 0 or infinity over infinity. Then you take the derivative of the top and the bottom. And notice how it's not the quotient rule. Okay, it's what we call, you just take the derivative of the top and derivative of the bottom. Okay, using L'Hopital's rule to find the limit. Now this is really important for the AP exam, for when you are justifying that you need to use L'Hopital's rule, is you need to actually show them the plugging in. You need to show that 0 over 0, so we use L'Hopital's rule. Okay, you need to write that. I'm going to be looking for the 0 over 0 or infinity over infinity, L'Hopital's rule. What I recommend you do is over on the side, take the derivative of f of x, which is 1/2 4 minus x 4 plus x to the negative 1/2, and the derivative of g of x, which is 1. So now you can say that this limit is equal to this value. And I keep doing that. Okay, now you can say this. Now plug in 0. So our limit ends up equaling 1/4. Now use L'Hopital to find this limit. Technically, cosecant and cotangent are discontinuous at pi. So yes, when I plug in pi, you technically have like undefined over an undefined, or an infinity over infinity. So what we do for L'Hopital's rule is we look as we go to one direction. So the left limit, and then we'll look at what the right limit does. Okay, so plug in. So the cosecant, why can't I write cosecant? It's not negative pi, it's to the left. Okay, this would be infinity over infinity. So we need to use L'Hopital's rule. Okay, again, notice how I've written out the infinity over infinity, L'Hopital's rule. So now take your derivative. Okay, we have f and we have g. I'm going to do my derivative of f of x over here to the side. Cosecant is negative, cosecant x, cotangent x, derivative of g of x, is negative cosecant squared x. So then I can say my limit as we go to x from numbers a little bit less is equal to the negative cosecant x over the cotangent x. Please show me this derivative. We'll simplify in a minute. So then simplify that. The negative simplify and one of your cosecants canceled, so we have cotangent of x over cosecant x. Simplify this even more. Cotangent is cosine over sine. 1 over cosecant is sine. So this simplifies to this. So we have the cosine of x. That limit is equal to a negative 1. Now for the other side. So the limit as x goes to numbers a little bit more of our cosecant of x over 1 plus cotangent x. We would get a negative infinity over a negative infinity. Okay, so again, L'Hopital's rule. So show me the derivatives. We've already done a lot of this work. So as long as you show me the derivatives, that you recognize that you want to do a derivative over a derivative, and then you simplify that to your cosine, okay, because we did that simplification over here, so I'm okay if you jump to this step now on the second part. When cosine of x, well, that is also equal to a negative 1, so this limit equals a negative 1 by our L'Hopital's rule. Okay, please for me, make sure your lesson summary, which is below this video, is submitted on time.